The goal of this video is to try and give you some tips on how to code a static equilibrium problem. So again, there's going to be a starter code. Hopefully I remember to put the link in there in just a second. But yeah, so give me just a second. All right, let me share screen. Okay, whoops, that's the wrong one. Let me go into here. Let me go into here and let's go into, I think it's this one. So this will be the starter code that I eventually make available to you. All right. And so right now, let me just show you what we're trying to do. Whoops. Uh-oh, what did I forget? Line 53. Whoops, I forgot to comment out something. There we go. So let's run this really quick. All right, so this is not very exciting right now, but if I could zoom in here and maybe give you an idea. The goal here is we see a beam and there's a mass on the end of that beam. And then this has a pivot point right here. So that sphere is supposed to represent the pivot point. This large gray box is supposed to be the wall. And then there's a hanging mass over here at this end. And hopefully what we can eventually do is connect the cable. And we can connect the cable at different points. So maybe we want to connect the cable a little bit higher and have it connect to the rod a little bit lower, or various things. So there's many variations we could do on this thing. But the idea is I've given you hopefully a starter code that's going to show some of this. Now, let's go in and talk about some of this stuff really quick. I thought I hit the clear annotation. Sorry, let me do that again. My screen's lagging right now. Clear, so laggy. There we go. Sorry about that. And so, okay, so I'm going to define a length of the rod, and it turns out later on, maybe we're going to have the cable be the same length as the rod. Okay, so there's two masses. One is the mass of the rod itself. The other is this large hanging mass. And so these parameters are actually set up to match one of the YouTube videos that I actually showed in class, hopefully. So yeah, I'll try to put a link to that video in the comments too. Probably should make a note here. Comments. All right, sorry about that. This is the kind of thing I would forget. Anyway, so this gets rid of a lot of the boring stuff so that you don't have to do all this boring drawing. Notice here, though, let's talk a little bit about this. I did some tricks here. So notice the hanging mass. Where is it located? Its position is at the rod's position plus the rod axis. Now remember, what does that do? It says get the rod's position. The rod was made from a cylinder. The cylinder attribute's position is at the center of one face. And then the axis up here was some axis, where was it? Oh, there it is. The axis is basically the rod's length in the x direction. Got it. So that's going to go over distance L. And then I subtracted a little bit. This particular number doesn't really matter, but basically I just had it drop down 3 times the block's height just so I'd have room to see it. Okay. Now I drew a little string to connect those. And yeah, this stuff is really boring to get. It's tedious, but it helps visualize it. And so I think there's some merit to that. Now notice by doing this, this is a convenient way of doing things because then if we move things around or change the rod length, this should all still be good. All right, now in the end, I'm hoping your code will end up looking a bit like this. Now at first it doesn't, you can't really see it, but what I did here is I created a code which will animate the position of the cable, and it'll show that in just a second. So right now the cable is attached very, very close to the wall, or very, very close to the pivot, and as such the force arrows are huge. But as we rotate this, okay, so now we could start to see what's happening here. Notice there's a plot of tension versus X, and now the tension is finally there. Notice I'm showing you both the reaction force and the tension in the cable, and we plot this. So that is your goal for this assignment. And notice you can see the X coordinate in meters is changing. We see this huge tension at the beginning, And then there's this large region where it doesn't really seem to matter, almost anywhere between about 0.5 and maybe 0.85. The tension is almost the same throughout that entire region, regardless of where you connect the cable. And that was something interesting I discovered. Also, I wasn't expecting this right at the beginning. We see this start to blow up. The fun part is thinking through why that actually is reasonable. And I'll let you do that, or we could talk about that. But again, that's your goal.